Hello, cat aspirants. Welcome to another episode of Bell the Cat series. Today, we will be looking at a DILR problem from CAT 2024. So, let's get started. So, in this problem, we are given 10 numbers and we have to place those 10 numbers into 10 slots in the grid which is shown in the problem. This is a typical mapping problem where each number has to be placed in one of the 10 slots that are provided. If you have a deep look at the figure that is given, you will know that from whenever we go from rows R1 to R4, the number of slots are decreasing. So in R1 we have 4 slots, in R2 3, in R3 2, and in R4 1. And in if we consider columns, for columns it's the opposite. Column C1 has only one slot, then it keeps on increasing, 2 in C2, 3 in C3, and 4 in C4. And then we have some information regarding the placement of the numbers in the slots. So first of all, whenever the numbers are being placed in a row, they increase from left to right, and whenever the numbers are placed in a column, they decrease from top to bottom. Then we have certain cases as well, like 1, it's either placed in the same row or in the same column as 10. So 1 and 10, they go in same row or same column. 2 or 3, they don't go in the same column or row as 10. Then same 7, 8, they don't go in the same row or column as 9. And 4 and 6, they go together in the same row. Try to remember this information as much as possible once you read this problem, because this is not an information heavy problem like the gymnast problem that we saw. This is more of a mapping problem. This problem will have a lot of possibilities coming into it. So let's get started. So whenever we have a problem in which there are a lot of possibilities, where there is, you know, a lot of sequence and ordering of numbers, in that cases, always try and start with the edges, the edge points. That will actually try and restrict the number of possibilities, and you will be able to freeze the information more faster. Eventually, you'll be able to reach the solution faster. You can still try and start with the center points. For example, I can start with the center point here, like 4 and 6. Those are the center information here. 10 is an edge location, since 10 is the greatest of all the numbers that we have to place. 1 is the smallest number that we have to place. Center points are like 4, 5, 6, which are not towards the end, like they are not the greatest, not the smallest. So if I try placing 4 and 6, so the only information I have regarding 4 and 6 is that they go in the same row. So if I try to place 4 and 6, I can place it in first slot in R1 or in second slot in R1, or so on and so forth. So there are many possibilities in which I can place 4 and 6 in. And whenever you're trying to solve any problem in DILR, the main objective is to narrow down on the possibilities, not to widen the possibilities. Because if you keep widening the possibilities, you will never arrive at a solution, or it will take huge amount of time to reach the solution. So we'll be starting with the edge points first. So we will be starting with 10 first. So what do you know about 10 now? So let me start placing 10 at a random location. So I might place, 10 in second slot of R1 here. So if I place 10 here, then there is no number smaller than, or sorry, no number greater than 10 which can be placed here or here, since this is going to increase from left to right. Similarly, if I place it in this position, in first slot of R2 or in second slot of C2, right? If I place it here, then there is no number, greater than 10, which I can place here, because column wise we are going from greatest to smallest in the descending order. Therefore, I can only place 10 towards the edge, at the last row of R1 or the first slot of C4. So this is the position where 10 can be freezed because of the information that we have. So we have 1 point freezed now. So we have just 9 more points now. So we have already reduced the possibilities, you know, by 1. Now, let's look at the another edge point that we have. That is 1. So 1, the information that we have regarding 1 is it is placed in same column as 10 or same row as 10. So this will either fall in any of these 3 rows in R1 or any of these 3 columns in C4. Any of these 3 slots in R1 or 3 slots in C4. Now, if I place it here again in the second slot of R1, then what will happen is there is no number smaller than 1 that I can place before it in the first slot of R1. Hence, I'll have to place it either in the first slot of R1 or in the last slot of C4. So these are the two possibilities where I can place 1 at. Since this is not 100% freezed, this is either or. I'm using the amber color to mark the point of 1. So I'll be placing 1 either in the first slot of R1 or in the last slot of C4. So these are the two possible. One of the between only these 2 points, 1 can be freezed. Now let's now start moving towards the center. Now let's start placing 2 and 3. Why 2 and 3? Because we have a condition which is applicable for both 2 and 3. Hence, we'll keep 2 and 3 together. Now, you might have a question here. Why I am not starting with 9 now? Since 9 is also a similar point like 2 and 3. So, imagine the situation. If I'm placing 9 now, so where I can place 9? I can place 9 either at first slot in C3 or in second slot of C4 because then I'll not because I don't have any numbers, greater than 9 which can be placed in slots before that one. So I'll have to place it either in third slot of R1 or second slot of C4 here. So if I place that there, then I have multiple other options, multiple other points that I have. For example, 4 and 6. I'll have to place 4 and 6. I have multiple possibilities to place 4 and 6 then. I can place it in row R2, I can place it row in R3. So if we consider that particular node, right, where we are freezing 9, that has multiple other possibilities. Like if I freeze 9 here, then I will have one node and I'll have 2 more, 3 or more branches coming out of that particular node. But if I place 2 and 3, that will actually solidify two places of integers, two integers at the same time. So it will actually try to drill down on the information which I already have. So hence, we always tend to go towards the node where you have lesser number of possibilities, which will be emerging out of that particular node. Hence, we'll be going with 2 and 3 first. I might still be able to get the answer if I am, placing 9 first, if I'm trying to place 9 first. But it will take me more time to reach the solution then. That's why I'll be starting with 2 and 3 first. If you start with 9, let me know in the comments how much time you take to solve this particular problem. So let's start with 2 and 3 now. So what information we have regarding 2 and 3 is that 2 and 3 will not go in the same row or column as 10. Hence, the complete row R1 and the column C4 can be removed from our consideration. So now we have only these 3 slots. The first slot and second slot of R2 and first slot of R3 that we have. Now, let us assume I place 3 here, just randomly. Then I will have to place 2 either in the first slot of R2 or in the first slot of R3. Let us assume I place 2 here. Now, there is no number smaller than 3 which is available which can go in first slot of R3 because 1 is not going to go there. So what I can do here is I cannot place 3 in this particular slot. Same is with 2. So I cannot place 2 in the slot as well because there will be no number smaller than 2 which will go in these two corresponding slots. Hence, I will have to place 2 and 3 in first row of R2 and in first row of R3. But yes, 2 and 3 can go interchangeably in these two slots. I can place 3 in first slot of R2 and I can place 2 in first slot of R3 and vice versa. That will not make a difference. But these two slots will have 2 and 3. That is freezed. Now, let's start. Now let's try to place 9 because now we have at least 2 more slots that have been freezed. So out of 10, we have freeze 3 slots and we have one which, we have some information regarding one also. So now let's try to place 9. So as stated earlier, right, 9 can only go into these two slots because there is no number smaller than 9 which can go beyond 9 in these slots here. So I'll have to place 9 here only. If I place 9 here, then there is no slot, no number which can go beyond 9, which is greater than 9, because 10 is already freezed. So there are these two options for 9 which are available. Now, let's now consider the first case where 9 is placed in R1. Now, if 9 is placed in R1, then 8 and 7, those two numbers, they don't go in the same row and column as 9. So they will not go in this particular section of the diagram. So the only place they can go is in column C4. So, and since 8 is greater than 7, I'll have to place 8 first. So if I place 9 here, I'll have to place 8 and 7 here. And now, since I have 4 and 6, which go in the same row as, together, so I can only place them in R1. If I place 4 and 6 in R1, then I'll have to freeze 1 in C4. So what I'll be doing is I'll be freezing 1 in C4 and I'll be placing 4 and 6 in R1. And the only number left is the core of the problem, 5, regarding which we have no information also. So we'll be placing 5 here. So this looks like a possible solution. This is satisfying all the information that has been provided to us. There is no information, that this particular, solution, possible solution, it does not, you know, interfere with any of the information that we have. Now let's look at the condition where we'll be placing 9 in R2. Now if I place 9 in R2, then again I cannot place 8 and 7 in R2 or in C4 because they don't go in the same column as 9. Hence the only option I have is to place 8 and 7 in R1 right here. But now imagine this. If I have 8 and 7 placed here, there are no two slots available in the same row for me to place 4 and 6. Hence, this particular solution is not possible. Now, let's take a step back and again analyze the situation. Let us assume we would have gone, we would have started to solve this problem by, using the node of 9 first. Then what would have happened? These two slots where we have 2 and 3 right now, we would not have solidified that particular information. So what would have happened? In this particular case, I would have placed 9 here as usual. I would have placed 8 and 7 here. That also would have been as usual. But I would have these two slots open and these two slots open again. So I would have tried to place 4 and 6 here. If I would have placed 4 and 6 here, then these two slots would have been open. Then, or if I would have placed 4 and 6 here, then these two slots would have opened. So I would have two more branches coming out of this particular point. Then what would I have done? I would have again tried to place the remaining numbers there. And when I would have reached the point where I would have tried to place 2 and 3, then I would have realized that I cannot place 2 and 3. So at that point of time, I would have marked that particular path of that particular node and all its following nodes as not possible. So that would have consumed a lot of time for me. Hence, always try to go with the path or with the node where there are less number of possibilities. Then only you will be able to solve the problem faster in DILR. Okay, so this solution is not possible. So the only possible solution that we have is this, where 9 is placed in R1. Now, let's look at the questions that we have. The first question is, what is the row number that has the least sum of numbers placed in that row? So if you see the rows, right, R4 only has one number, which is 1. So obviously the answer here would be row number 4. Pretty simple. Next we have two statements here. First statement says 10 is placed in a slot in row 1, which is true, and then 1 is placed in a slot in row 4, which is also true. Hence, both 1 and 2 are true in this case. So the correct option is option A. Next we have is, which of the following statements must be true? Again, we have two options. So 2 is placed in a slot in column 2. No, it can be placed in a slot in column 3 also. And 3 is placed in a slot in column 3. Again, it might be placed in a slot in column 2 also. So neither of these two statements are true. So we'll go with option C. This is because the word must is there. If if it would have called possibility, then this might be the answer might have changed. But since it's a must, then it's option C. For how many slots in the grid, placement of numbers cannot be determined with certainty. So we know that 8 of these numbers have been freezed correctly, like with certainty, but 2 of these numbers we don't know the exact position. So the answer here is 2. Then what is the sum of numbers placed in column 4? So column 4 has 10, 8, 7 and 1, which sums up to 26. So answer here is 26. So what are the secret tips, or what are the points to remember from this problem that we can note down? First is, whenever you're trying to solve a question which has an order, which has a sequence of numbers, always try to start the problem with the edge points. That will help you, narrow down the problem faster and solve it faster. Next is, when you are trying to select nodes while solving a problem, always prefer a path where the number of possibilities is lower than the other. This will actually freeze the information faster, as we have seen, right? If we would have gone with the node of 9 first, then we would have to evaluate more possibilities, and that would have reached the answer, but we would have taken a lot of time. So this is something which these tips will help you solve problems faster in CAT. So hope you have learned something from this particular problem. Tell us in the comments what DILR questions you want us to solve next, and we'll try to select those particular problems for our next episodes. Till then, stay motivated, stay focused, and see you in the next episode.